Hello everyone, my name is Priyank Patel. I'm VP of Product Management for Machine Learning at Cloudera. Today I'm going to talk about how an optimized ML lifecycle increases the return on investment for a lot of the AI projects that our customers run on our platform. But before I go there, let me start out with an interesting trivia actually. There is an island in the Caribbean off the coast of Puerto Rico. It's the Caribbean island of Anguilla. And if I were to pose it Jeopardy style, if that was the answer for all you AI folks out there, what would be the interesting question? I'll give you about 3 seconds to type it up in the chat before I go to the next slide. Okay, the question would be, which country administers the domain .ai? So any interesting .ai company, project, website that you've come across is all administered through this nice, tiny Caribbean island of Anguilla. It's an interesting piece of trivia because as we at Cloudera work with our customers, we find that thinking of AI and ML as islands of projects and islands of systems in and of itself almost always never scales. And let me explain how. AI platforms are intertwined in their success with a lot of other technology adoptions that we see out there. Of course, cloud, Kubernetes, and container-based compute environments are evolving, and being able to develop, deploy, and maintain the entire lifecycle of your project across different clouds, on-premise data, in the cloud data is relevant and important. But at the same time, once you develop the models, being able to deploy them on the edge, being able to deploy them on streaming data is extremely important as well to get maximum value out of it. And the last thing that almost everybody on the call will agree with me on is there is a very high amount of interest in what we do here in AI and ML, but there is a relatively low amount of expertise. If you go outside of the core expertise of data scientists, the ability to leverage technologies becomes less and less easy to find. And all of these are relevant because if organizations are going to think of AI investments as beyond just being single island style projects, then some of these are parallel tracks of adoption that are moving that need to be addressed. Let me start off with a customer example. A customer of ours, United Overseas Bank, large bank with extremely large amounts of data, in this case 2 petabytes and growing, data about the entire enterprise from the customer interactions, several million customers, over to internal processing of that data as well. When they started out in a single project in a single group for anti-money laundering and AI and ML modeling team, they were obviously able to get interesting, good results by reducing false positives up to 60%. But the higher value part of this is that using the exact same data, the exact same tooling, they have now been able to get 25 different teams of ML engineers and data scientists functional on the same platform. So now the loan department is using the same data and the same AI technology, as is the customer churn analysis department. The propensity modeling team is using the exact same piece for other actions that the customers are performing as well. And that really leads to the top level headline that I have on my slide, which is 40% increase in the operational efficiency that they see across the entire business, right? Not just about a single project, but now across multiple dozens of projects in different business teams. How does this work, and why are they able to realize these benefits? And it goes back to thinking of data engineering, machine learning as within a life cycle of data. The data almost always goes through these 5 stages of the life cycle as I described on my slide over here. It is streaming, and it gets collected and flows into the system. It's curated, and a lot of the curation happens through data science and through pipelines that we call data engineering. Of course, the same data gets reported on. It's served through key value stores and operational systems, and naturally, it's used in the ML development side to develop the models and to fine-tune the models as well. The value of thinking of the data in a life cycle is that once you collect and curate and make the data available for a single project, it can then be automatically leveraged across multiple projects as well. And that's something that's repeated value that will be realized as you scale the AI discipline out across multiple organizations, and particularly in large enterprises. That's valuable. The Cloudera data platform actually allows our customers to leverage the data lifecycle and pick and choose what we call experiences that allow computes of these different flavors to run in the data center, i.e. on-premise, as well as in the multiple cloud, public cloud options, Azure, Amazon, that are available. So the idea that your data is hybrid, whether it's on-premise or in the cloud, the compute is exactly behaving the same way because the compute is built on technologies like Kubernetes, and the data is managed through our common security and governance layer, which we call Cloudera SDX. So once an investment of the data lifecycle has been made for a single project, it can be quickly leveraged across different teams as well. So that's the first interesting way in which a platform view helps get better ROI as the adoption of AI goes beyond individual teams in your companies and organizations. The second one is worth considering is who are the end users who actually interact with each one of these lifecycle phases. As the data gets piped into the system, the data pipelines and the jobs that are running, that's a large amount of work that data engineers tend to perform in an organization. And the data scientist sitting in the middle where they are developing the model, perhaps generating a packaged model, and then helping or determining what to monitor in the model and making sure that it's served. That's the core task of the data scientist. And then last but not the least, on the absolute right of my slide, you will see the business users who are the ones that need to leverage the modeling data that is being done. So a lot of citizen data science gets done because there are the business users, of which several thousands of them across organizations need to be able to leverage the machine learning work that is being done and being able and do so without the reliance on highly skilled technical individuals. If you take the pieces of the lifecycle out, the three personas are of interest, and we'll see how each one of them have different needs. They have distinct requirements, but they have a common goal, obviously. So let's start off with the data scientist. They care about a collaborative development environment. They want to think in terms of projects that are shared across teams. Each of the projects, they need different types of editors. They need different kernels, whether it's Python, R, or others. And of course, they have distinct CPU, memory, and GPU requirements. Resource requirements are the natural ask that you get from data scientists. And being able to provide that persona, that data science user, the ability to work in an isolated development environment is core and first and foremost to doing it. Second is you need to provide some sort of an interface for doing the IDE. Notebooks happen to be the most common interface. Interestingly, Kaggle tells us that only about a third of data scientists out there actually prefer or actually use notebooks. There is users of RStudio. If you're obviously doing R programming, RStudio is by far the most preferred. PyCharm, VS Code, Zeppelin, and many other editors that also are required. And it's important to support a wide variety of those in your development environment because oftentimes editors are more tuned to the particular language in which the development is occurring. The next one for data scientists, it's important, is use cases in ML are repetitive, i.e. the same kind of use case keeps getting repeated. Propensity models for different kinds of use cases are still at the base, following the same patterns of building a propensity model for a customer. The patterns are also repetitive, meaning the way in which you are going to build an image analysis or a semantic analysis application is going to be the same pattern that will be applied over and over again. And many times it's not just within organizations, across companies and across industries, we find this repetitiveness in the use cases and the ML patterns. So what do we do? How can we leverage this commonality while making sure that obviously each group each team and each organization has their specific way of modifying and applying this pattern. So at Cloudera, what we do is we have a team in Cloudera called Cloudera Fast Forward that performs applied machine learning research, and we publish these applied reports. These are reports that that use interesting cutting edge technologies, cutting edge ML research, but they tie it up to a independent problem, to a problem that we are seeing at some of our customers, or we are hearing from the community. And each one of those reports is an interesting way in which a pattern of how to do, for example, how do you do NLG, or how do you do deep learning for particular image analysis? How do you put together the pipeline, or the feature engineering for that is described. What we're doing to bring this to the next phase, to get data scientists more than just a report or an interesting article or an interesting blog post, is to essentially build what we call applied ML prototypes, or AMPs for short, which are end-to-end prototypes of the life cycle that I was describing, that help kickstart or jumpstart these customer use cases. Right? So what do they look like? When you look at them, when a data scientist logs in, there's a catalog of AMPs that they find. This catalog is openly available. It's sourced from a Git repo. So each one of the icons that you see on my screen is a declarative AMP that has been sourced from a master repo that is pulled, and that can be published separately. And each one of those has a full end-to-end application that has been built out, from some sample data to how the model was put together, to the actual packaging of the model, and to the absolute building of the end application in many cases as well. So when someone clicks on one of these, let's say I clicked on the churn modeling XG boost example, or AMP, and I launch it, it literally goes and sets it up right there and then, the 10 steps that are required, including the sample job to train the models, including running the job, creating the endpoint, or essentially taking the model, packaging it, and creating an endpoint. And in many cases, also the end application. So we'll probably put a default Flask-based application that would show how somebody can interact with this, with the analysis that's being done as well. This is of interest because what Cloudera does is we seed these AMPs based on the applied ML research, but we keep it open. We keep it open in the sense that anybody who wants to take these and contribute more AMPs can easily take the Git repos or the projects that we have and publish their own without going through us. So it can help build a set of projects within a team, or a set of projects within the community that can be leveraged and reused over and over again. The second persona, let's go into data engineers and ML engineers. And here I'll start out with a little bit of an eye chart over here. But the idea is that if you try to answer the question, the engineering question that gets asked of these personas is, how do you scale the number of models being deployed? There's a lot of models that are being built. That's great. How do you now reliably deploy them? Make sure that they are monitored. Make sure that the data is being fed on a regular basis. And if it is not, if pipelines are breaking, then you have appropriate fixes or appropriate remediations in place. And this is where Cloudera takes an approach, which is where the perception is always from the data science side, is that data engineering is part and parcel of data science. Data engineering means transforming the data, building repetitive jobs, and scheduling and keeping them up to date is part and parcel of data science. And therefore, if I have a data science tool which is helping me build my models or automatically generating my models, I should also have my job scheduling, etc. ability right over there. What we do instead is we realize that data engineering oftentimes is done by non-data scientists. Oftentimes, the engineers pick up the perhaps initial and oftentimes haphazard code that's being done on the data science side and productizing it or operationalizing it orchestrating these pipelines, running them at scale, making sure they are profiled, tuning the performance so that the price performance is acceptable because these now run on a regular basis, and then making sure that they are fed into the models that are trained and readily available from the data science projects. And so what we split out, we essentially focus and give a very simplistic experience or a service for data engineering that ties at the hip with how data science is being done inside our platform. That is done through in Cloudera, a Cloudera data engineering service, which allows large-scale pipelines for data operations in CDP. What it is a containerized Spark service with Airflow orchestration and visual troubleshooting, because those are the kind of fundamental things that an engineer, a data engineer cares about, is A, quick auto-scaling of compute, B, rich orchestration, and Airflow is very popular for orchestration, and the ability to quickly troubleshoot, starting with logs, obviously, but then visually being able to pinpoint where the where particular pipelines are slowing down or speeding up. And then obviously, it goes without saying that all of this has to be orchestrable through APIs. In other words, in the world of data engineering, a lot of the orchestration has to be available through programmatic interfaces, in addition to what you can do through UI. So let me go into how autoscaling works on Cloudera data engineering, where you have the isolated virtual clusters that go up and down, or that consume more resources as required for different ETL workloads. Airflow-based orchestration, where you find Airflow DAGs that can be automatically plugged into the system. Those DAGs can be as complex or as rich as the data engineer wants them to be. Visual troubleshooting, where you see different stages of the pipeline, and particularly the stages that are creating or taking more time when let's say you're looking at SLAs, or in some cases when there's failures, you can immediately go to the stage of the pipeline that's actually failing. But the interesting and the most important part of this is, while all of these pipelines are running, in Cloudera, we have the ability through SDX to capture the lineage. So when the raw data shows up in an object store like S3, running through a Spark job inside Cloudera data engineering and ending up into a target table that gets then downstream usage across the model, we capture the lineage so that at any point in time, for governance purposes, you can always go back to the exact same set of data or exact same copy from where, or jobs from where the data was spiked. The second part of governance or of engineering is the ML engineering, where training is complete and you're packaging and serving and monitoring the models. And that is completely tied at the hip, as I said, in our view in the platform as well. The way this shows up, again, from a governance side, starting out at the governance level, is it ties what you see on the left, the top left of my screen, which is data going through different phases, and it marries it to model operations, meaning the model training that was performed. So now you can tie back to a training that was done on a particular table, a particular subset of the data that was used for the training, and you can actually audit that at any point in time. Extremely important, particularly because the rules behind what can and cannot be used for training and how AI ethics is evolving is something that all organizations track on a pretty regular basis, and having this ability to be able to at least have the visibility into how certain operations are working is extremely paramount before you can actually think about tweaking the rules of how policy is set. Up until the right, where you're serving the models, where literally on the right is an endpoint of the model where calls are being made on the REST API and results or predictions are being served from there. And this entire life cycle is served within the Cloudera data platform, and the auditability is shown within SDX that's tied at the data platform here. Last, I'll jump into the persona of business users. or citizen data scientists or non-technical users who are extremely interested in the work that gets done in machine learning. One of the things that we do here at Cloudera is we integrate. We realize that a lot of applications get created once models are built. So what we've done is we've integrated the more traditional BI dashboarding, but we've essentially brought it into the ML world by integrating actual real-time model calls from dashboards and from drag and drop kind of analysis directly inside our machine learning platform. So the way this manifests is Cloudera machine learning, which is where the data scientists do their work and publish their models, the part that we just saw, automatically now presents an interface that allows you to do more drag and drop style application building, which starts out with individual visuals, multiple visuals put together in a dashboard, multiple dashboards put together into an application. How does this look, or what does this essentially enable data science teams to do? Is to quickly tie decision makers and business teams directly to the work that they're doing. So instead of waiting and writing lines and lines of code and then trying to figure out how the end business users need to consume this data, what data science teams can do is to quickly enable these decision makers, give them the more drag and drop capability, and they can make calls directly into the published models and get insight without waiting on a lot of code that has to be rewritten. So it augments a lot of the analysis that the business is trying to do and leverage the AI work for day-to-day decision making that's fundamentally required at the end of the day. The application creation is business user friendly. It requires zero code. It gives you recommendations, and now the persona has changed into somebody who's not a code friendly persona. They actually get visual recommendations on how to visualize the data. An interesting piece that we are adding this year is actually applying AI in this experience itself. So we are enabling natural language based interaction with the data, where you see over here, the end user is typing up a query, population trends by year and state as a tree map in this case, and that is automatically figuring out what should be the underlying query, which model, if I were to actually wanting to query a model and look at a prediction, there would be keywords like prediction that would essentially call the model, and it would automatically figure out what is the right way to visualize the data and show it to the end user. You can imagine the stuff on the right, or the way in which you interact on the right, is something that is explicitly designed so that a non-data scientist or a citizen data scientist can actually leverage the AI work that's being done. The rich visual applications that you can build are pretty varied in nature. So you see over here, there's maps that are included. There's obviously filters, and in this case, I'm actually checking for something called the likelihood, which is not surprising. This is coming from a model that is deployed, and I'm actually making calls into the model in real time from the dashboard before showing, in this case, clusters where a certain likelihood for customers is showing up, or for these customers is showing up. An example of a customer who is actually is tying this up, not just using machine learning for data scientists, but then making that more and more accessible to end users as well, is Globe Telecom, which is the largest telecommunication provider in Philippines, the country of Philippines. Again, large amounts of data ingested on a daily basis, about half a petabyte in their case, ingested on a daily basis. And what they do with Cloudera's platform, because they have data both on-premise as well as in the cloud, they are able to leverage Cloudera's platform CDP and CML, machine learning within there, to use the same skill. The same users who are leveraging the system on-premise can leverage the exact same system to work or burst the compute on the cloud, because in some cases there is the need to use infrastructure and compute on the cloud, and that's what helps them generate optimized loan models. In their case they serve about 93 million customers, where they're doing churn and cross-sell analysis right over there. So in summary, I'll end with the same thing that I started, which is the island of Anguilla and AI not being an island. To get better ROI from your AI projects, it should be thought of, your AI project should be thought of as part of a platform, so that the work that is done by a single team, by a single project, is leverageable or is reused. You don't have to rebuild everything from scratch, and everything and the data has to be re-ETL'd or re-prepared just because a new project showed up. Because within the enterprise, the set of data is obviously common, and you want to make sure that some of those investments get leveraged over and over again. That's where the real return on the investment starts showing up in your ML lifecycle. Thank you very much for your time, and I hope to get some questions from you. I'll be around for a while. Thank you.
All right, let's get Priyank up for Q&A.
Hi, Sam.
Great presentation. Welcome, Priyank. Let's take a look in the chat, which you've been keeping up with, to see if we've got some unanswered questions. It looks like there's an opportunity for folks to dive in with questions. One that I've got is around this idea of enabling the citizen data scientist, which you spoke about quite a bit. And I was wondering if you could elaborate on the differences between deploying a model for citizen data scientists versus deploying a model to be consumed by applications and systems. Are there differences that you need to be aware of?
Good question. I think when you're from the data scientist perspective, if you're deploying models, you're obviously expecting applications and end users to be calling them. So from a scale perspective, I don't think it makes too much of a difference. Where it does make a difference is the accessibility. Oftentimes you deploy a model, you provide a REST API to the model, you publish it if you do a slightly more thorough job of it, and then you leave it at that. That is largely useless to a citizen data scientist. They're not going to go and write code to make calls, much less an application or a web app around it. And so making it more accessible to them, if there are tools that they're using, make sure that you provide that connector so that they can call into the models as well, and not just with the REST API. And you'd be surprised, it's that last bit which will kind of make the regular day-to-day business user just go about their way, pull up Excel and start doing the more statistical trending that they always fall back to. So that's just one of the distinctions we see.
Mm-hmm. You spoke quite a bit about the data lineage and the importance of being able to track that from the source of the data through to the prediction of the model. Are there other elements that come into this broader context of explainability that you enable?
Yeah, so I think we start out with the lineage tracking, which is core and the starting point around monitoring of the models first, and then going on to explainability. But monitoring of the models, there is oftentimes missed or a hard problem to crack, which is how do you compare how the model is performing with what happened actually in the real operational system, i.e. the concept of ground truth, and how do you marry that over. So what we do in Cloudera, what I was describing over there, it is built on an open API-based or an SDK-based system where metrics that are collected, the default metrics that we collect part of the system, that's great. But we expect quite often that data scientists will actually start tracking different and monitoring different metrics around it, which will then be married over to the actual operational systems for ground truth monitoring as well. So that's number one. And then explainability of the models, it comes obviously from the development side and making sure that the right algorithms are used in terms of actually development of the model. And to make that easier, as you saw when I was talking about AMPs, making a lot of the repetitive tasks quickly and easy to use. Reading a paper on SHAP is great. If I have an end-to-end project that leverages SHAP and quickly shows me how I'm building an explainable model, I can wire that up rather quickly to my problem, even though the problem set from the AMP is not exactly what I'm trying to solve. So that's how we are addressing making that more accessible or quickly usable.
Okay, great. We'll take one more question from Pablo. Are there any fail safes that you tend to see folks putting in place for citizen data scientists to minimize things like model risk or them not understanding the predictions of the models or otherwise?
Yeah, I think you can't expect the end users to always make or use the predictions or the results of the model without the context that you provide. So the way in which we've seen customers do that is you have to follow through and make sure that you are giving them examples of where and how the interpretation of the results of the models are. And also, if it goes so far as a next step, to actually recommend that, or to recommend or proactively call out the limits of what you think this should be used in independent decision making. As an example, I'll give you an example right within our company. We have a team in Cloudera, and they were building something related to COVID. So obviously, they're building some models around COVID, around our offices and remote locations. And the absolute first thing that the data science team brings up is the best epidemiological models are still going to fail. And so what you want to use this as a it's a standardized way of adding one decision point to a certain decision that HR is trying to make in our company, but it's by no means the only way in which you should hang your hat on. And so that came directly from the data science team. It was upfront when they published that model.
All right, great. Priyank, thanks so much for your presentation and for joining us for the Q&A. It's great having you.
Thank you, Sam. I'll see you in Anguilla.
Absolutely.